Let's go ahead and find the antiderivatives of these functions. These are from Openstax Calculus Volume 1. And this first one maybe even has a little typo. What I want to say is that f of x equals 2 sine x plus sine 2x. Okay, so the antiderivative is what we're going to write as capital F, such that f prime of x is equal to little f of x. Now, note that the derivative of cosine x is equal to negative sine x. All right, so we have to memorize that. Therefore, if I multiply by negative 1 on both sides, I get negative d dx of cosine x is equal to, so what am I doing? I'm multiplying just what I wrote above by negative 1, negative sine x, and those two negatives cancel out. I sort of don't even want to write the negative, just write sine x. So, okay, so if we look at this first one, what do I mean this first one? This first term of little f of x, this part right here, 2 sine x, the antiderivative is negative 2 cosine x from what I just wrote above. Let me highlight it and unhighlight it, but if I have what function, when I take the derivative, gives sine x, it's negative cosine x. See what I just did in orange? Negative derivative cosine x, which means the derivative negative cosine x equals positive sine x. So this guy, what I just wrote down, does the job. For capital F equals negative 2 cosine x. Yet another color, okay. This is a darker green. For negative 2 cosine x, you take the derivative and you see you get that light green 2 sine x. The next one's not quite as straightforward. For sine, well, the antiderivative, what I'm just showing is negative cosine. But this time we're going to have to use the power rule. If I take the derivative of cosine 2x, I get negative sine 2x, but I think I said power rule. I need to use the chain rule. But now what I do is I have to multiply by 2. That's the chain rule. But that means that 1/2 d dx of cosine 2x, actually negative 1/2, is equal to sine 2x. Why? Because if I multiply both sides of what I just wrote by negative 1/2, I get that. So in fact, come back up here. Put this in red. If I take the derivative negative 1/2 cosine 2x, I get sine 2x. So there's sort of playing around with things. There's a bit of guessing, and this is sort of an introduction to antiderivatives, in fact, and we'll get into way more of a detail of how to find antiderivatives. But there's our answer for that one. Sort of a lot of talking for that answer, but anyway. Let's go over here. This one I think is more straightforward. More or less, we're just going to think of a function. When you take the antiderivative, you get secant squared x. Well, which function's that? Note that the derivative of tangent x is equal to secant squared x. Hopefully that's something that that people have memorized. So capital F of x is going to equal tan x. That part corresponds to the secant squared x. How about 1? Well, x, when you take the derivative, gives 1. So if you have a constant and you take the antiderivative, it's that constant times x, and then plus c. And then you can check that f prime of x is equal to secant squared x plus 1. I mean, I don't see how that helped me really writing it down. Maybe I could just do that in my head a bit. But anyway, so there we go. at this stage, maybe always, there's a bit of a guess and check type thing. I'm going to, yeah, I don't know if I should erase or unhighlight some of these highlights I have here, but maybe unhighlight those and just have the answers highlighted. Okay, so let me zoom in as much as possible. So that gives everything, and that finishes this video.